Hey everybody, it's Mr. Kozad here. Getting ready to do a lesson for you on completing the square. If you're in my Algebra 2 class currently, that is section 4.5 from your textbook. Before we get any further in this video, first let me apologize. I know the sound is not the best. I'm working on a solution to get a little bit better audio quality, but for right now, this is what the best we can do. So if this is your first video lesson experience with me, what my expectation for you is that you are taking notes while I'm going through this, just like you would in class. The nice thing about a video is you can pause, rewind, fast forward. You can pace yourself through this however you need. I will go a little bit faster through this than I normally do in class. But like I said, if it's going too fast, please pause the video, go back, re-listen to it again. Do whatever you need to do, okay, to best keep up with what we're doing. Okay, so here we go. We're going to jump right in to our lesson. So if you don't have a notebook out yet, get it out, and we're going to take some notes together. All right, so here we go. Completing the square. The first thing you have to remember with completing the square is you have to remember your goal. Okay, so our goal with completing the square is you want to create a perfect square trinomial. You want to create your own perfect square trinomial. Now, what makes a perfect square trinomial convenient for us is it is very, very easy to factor a perfect square trinomial. Okay, so if you can get a perfect square trinomial, you can factor that relatively easily, and then you can solve that equation for x relatively easy as well. Okay, so here we go. Let's see how we're going to do that. The first thing that I do here is I see x squared plus 6x minus 5 equals 0. The first observation that you need to make is look at your lead coefficient. My lead coefficient here is 1, okay? The lead coefficient is 1. It's what's right in front of the x squared. Completing the square is super easy when your lead coefficient is 1. There's an extra step when it's not, which we'll talk about later, okay? So here's the first step that you're going to do. You're going to take the b value. That's the value in the middle. So in this case, we're going to take 6, our b value. And we're going to take our b value, whatever it is, and we're going to divide it by 2, and then we're going to square it. We're going to do b divided by 2 and square it. Here, that's pretty easy because when I take 6 and divide it by 2, I get 3. I got ahead of myself. And square it. 6 divided by 2 is 3. 3 squared gives me 9. 9 is very important to remember because that's what you're going to use to create a perfect square trinomial. So watch this. This is the part that makes everybody a little uncomfortable. Here's what we do. We rewrite this trinomial, x squared plus 6x plus 9. You're like, well, wait a minute, shouldn't it be minus 5 because there's a minus 5 in the equation? The minus 5 doesn't go anywhere. I'm just adding a 9 because my goal here is to create a perfect square trinomial, which we have in x squared plus 6x plus 9. Again, the minus 5 does not go anywhere. I kind of slide it out here to the side, and I'll use it later. Okay, and that still equals 0. Now here's the part that everybody always messes up. You have to remember, on the left-hand side of this equal sign, we added 9. So to balance this equation out, whatever you do to one side of an equation, you have to also do to the other side. So since I added 9 to the left side of the equal sign, I have to come over to the right and add 9 to keep the equation balanced. Okay? So now, here's what we can do. We can clean this up a little bit. Okay? We're going to go ahead and factor this perfect square trinomial. And here's why it was so nice for us to do that. X squared plus 6x plus 9 factors to x plus 3 squared. And then what I'm going to do is I'm going to take this minus 5, and I'm going to add 5 to the other side. So that ends up being 9 plus 5 gets me 14. So here's where we're at. We're at x plus 3 quantity squared equals 14. So then if I'm trying to solve for x, the next step is I'm going to get rid of the second power. So I square root both sides. So I'm taking the square root of x plus 3 squared and the square root of 14. The square root and the second power cancel out. So on the left-hand side, I just have x plus 3 equals plus or minus the square root of 14. Remember, it's critically important when you're taking square roots of both sides and you have variables involved that you need to remember your plus or minus. A lot of people will forget that. Okay? So then the last step is simple. If I want x by itself, I need to subtract 3 on both sides. So I get x equals negative 3 plus or minus the square root of 14. Now you may have put your negative 3 back behind the radical, so your answer could have looked like this. Plus or minus the square root of 14 minus 3. There's nothing wrong with that. I just feel like putting the constant before the radical, before the plus or minus, is a little bit cleaner looking. And that's typically how most mathematicians will represent their answers. So again, if you got to here, this is not wrong, but I just think that putting the constant first is a little bit better. Okay, the whole number first is a little bit better. So there you go. Okay, let's look at another one. Okay, example number 2, x squared minus 5x plus 10 equals 0. Okay, same concept here. We're going to solve this by completing the square. Now I look and see my lead coefficient is a 1. That's good. That's what I want. Okay, that makes this problem easier. So then remember, b over 2 squared. b over 2 squared is what you need to remember. b over 2 squared. Now this one's going to get a little bit more tricky because my b value here is odd, which means it's not evenly divisible by 2, but that's okay. Okay, we can handle this. So think of negative 5 halves as a fraction. Can you simplify it? You really can't. You could write it as a mixed number, but that's not going to help you when you square, so we're going to keep this as an improper fraction. So we're going to go ahead and square negative 5 over 2. So when you square fractions, you square the top to get 25, and you also square the bottom to get 4. Okay, to get 4. All right, so here's what we do next. We're going to create our perfect square trinomial. So we have x squared minus 5x, and we're going to add 25 fourths to create my perfect square trinomial. Okay, that's wonderful. Now, don't be one of the people that forgets about the plus 10 that was there originally. And also, don't be one of the people that forgets to balance your equation. Remember, you added 25 fourths to the left side of the equation, so to balance it out, you have to add 25 fourths to the right side of the equation as well. So now the next step is we're going to factor our perfect square trinomial. It's going to be x minus 5 over 2, quantity squared. Just a little trick that I've learned, okay? This sign, when you factor it, this sign will always match the sign of b. And this number here, the number you place here, will always be what you had at this step when you did b over 2. Okay, that's just a little trick to go a little faster if you want. Equals, I'm going to go ahead and subtract 10 to the other side. Okay, this is going to make some of you panic as well because I've got to do 25 over 4 minus 10. Now instead of writing 10, I could write 10, but that's not going to make it easier for me to combine those. So what I'm going to do is I'm going to write 10 as a fraction with a denominator of 4. So if I want that to be 10, I need this to be 40 over 4. 40 over 4. So then let's clean that up. We've got x minus 5 over 2, the quantity squared, equals 25 minus 40, gets me negative 15 fourths. Negative 15 fourths. So then what I can do is if I want to solve for x, I can take the square root of both sides. So the square root of x minus 5 over 2 squared equals plus or minus the square root of negative 15 over 4. So on the left-hand side, we have x minus 5 halves equals, now we've got to apply what we've already learned in 4.4 to clean up this radical on the other side. Okay? So let's go ahead and simplify this. We have plus or minus the square root of negative 15 over the square root of 4. We can rewrite the square root of 4 as a 2. And with the square root of negative 15, we can pull an I out so that it's I root 15. Sorry, I ran out of room there. Last step is to add 5 halves to the other side. So we get x equals 5 over 2 plus or minus I root 15 all over 2. Final answer. Not complicated algebra to get there, but if you just looked at the solution, you would probably think that it was pretty difficult. Okay? So there we go. All right, here's two more examples with a values that are 1 that I'd like you to try on your own. So what I'd like you to do is pause the video now, okay, and take some time and try to solve for x in example 3 and 4 by completing the square. Once you think you have your answers, go ahead and hit play again and you'll see if you were correct. Pause the video now. Okay, hopefully you're back with me now. If you didn't actually pause the video, this is really awkward, okay? I'm going to tell you to pause it, actually pause it and work. Okay, so I'm going to really quickly go through my work for each one of these. Okay, so when I create my perfect square trinomial here, I take b divided by 2, so negative 8 divided by 2 is negative 4. Square that, I get plus 16. Don't forget about the plus 3 that was already there. And also don't forget to add 16 to the right-hand side. So when I factor this, I get x minus 4 squared equals 13. When I subtract the 3, square root both sides, we get x minus 4 equals plus or minus the square root of 13. Add 4, x equals 4 plus or minus root 13. Final answer. Check yourself if you got that right. Now for example 4, same kind of concept. We're going to first create our perfect square trinomial. So we get x squared plus 11x. Now this one is a little bit more tricky again because 11 is an odd number. So you take b divided by 2, which is 11 over 2, and then you square that. So it's going to be 121 over 4, if you square that correctly. Don't forget about the minus 1 that was already there. And then also don't forget to balance your equation by adding 121 over 4 to the other side. Okay? So then if we factor this correctly, it'll be x plus 11 over 2, the quantity squared, equals, I'm going to go ahead and add the 1 to the other side. We'll go ahead and add the 1 to the other side. So I'm not going to think of it as a 1. I'm going to think of it as 4 over 4. So that ends up being 125 over 4. Okay, 125 over 4. So then we can take the square root of both sides, so we get x plus 11 over 2 equals plus or minus the square root of 125 over 4. Now hopefully you were able to simplify the square root of 125 over 4. We get x equals, if we subtract the 11 halves to the other side, plus or minus the square root of 125. Now 125 is not a perfect square, but it has a factor that is a perfect square. We can think of 125, I'll write it out here to the side, we can think of 125 as 25 times 5. If we think of that as 25 times 5, this 25 comes out of the radical as a 5, and there's a square root of 5 left on the inside. And that's all over the square root of 4, which is simply 2. So your final answer, negative 11 halves, plus or minus 5 root 5 over 2. If you got both of those right, you're doing a great job with this. Okay? If you didn't, maybe pause it now and go back and try to correct some of the things you did wrong. Okay? So here we go. Now let's have some fun. Let's see what happens when a is not 1. Uh-oh. America's favorite pastime is completing the square when a is not 1. Okay? If you can get this, this is hands down the hardest part of this entire chapter. Okay? So here we go. Here's what I see here. Clearly you can see your a value is not 1. It's not 1. Okay, very clearly we can see that. So here's what we're going to do. We're going to take this equation, and I'm going to separate it. Okay, watch how I'm going to do this. I'm going to think of it as like 2x squared plus 6x, and then the minus 3 by itself. Now you might think, Cosette, you didn't do anything different. You just introduced some parentheses there. You're right. It's the only thing I've changed is I've added parentheses. Now watch what I'm going to do here. On these first two terms, these two terms that I put in parentheses, I'm going to factor an x out of those two terms. So here's what that means. 2 times the quantity x squared plus 3x. And leave yourself a space. Leave yourself a space here because this is the trinomial that we're going to use to complete the square. So now we've turned this into one of the problems that we've done the first 4, where we have our a values equal to 1. Yes, there's a 2 that's factored out here, but I'm concentrating on this trinomial right in here. And inside the parentheses, my a value is 1. So now we use the same process that I've used before. Okay, b divided by 2 squared. b is 3 divided by 2 is 3 over 2. And square that, I get 9 over 4. Now, if you're not paying any attention to me right now, or you're doing something else while you're listening to this video, maybe listening to other music, or checking your Snapchat, whatever you're doing right now, stop. Stop what you're doing and pay extra close attention, because this is hands down the hardest part of this entire question right here. Listen. Stop what you're doing and listen. You know from the problems we've done in the past that we're adding 9/4 here. We're adding 9/4 here. Okay? But what we need to remember is I'm not going to add 9/4 to the right-hand side, because this 9/4 is inside the parentheses. And what is happening to everything inside the parentheses? It's okay to answer out loud. You can say it. Okay, good. Somebody in the world said you're multiplying everything in here by 2. So what you have to do before you add anything to the other side, you're actually adding 2 times 9/4. Again, 9/4 is what I put here to complete the square of this trinomial. But remember that everything inside these parentheses is being multiplied by 2. So while you wrote 9/4 here, okay, while you wrote 9/4 here, you're remembering that everything inside of there is being multiplied by 2. So to balance the equation, we add to the right-hand side 2 times 9/4. Okay? So now we can clear this up. We can do 2 times x plus 3/2, the quantity squared, minus 3 equals 2 times 9/4. Okay, when I do this multiplication, that 2 turns into a 1, and it changed that 4 into a 2. So that's just going to be 9/2. So then I'm going to add 3 to both sides. So we get 2 times the quantity x plus 3/2 quantity squared equals 9/2. Not plus 3. I'm going to think of 3 as 6/2. So then here's where we're at. We're at 2 times the quantity x plus 3/2 squared equals 15/2. Now we're getting closer. Before you square root both sides, before you take the square root, divide both sides by 2. Divide both sides by 2. So what I have is I've got x plus 3/2 quantity squared equals, now you got to remember some things about fractions. Dividing 15/2 by 2 is the same as multiplying that by 1/2. So that'll end up being 15/4. 15/4. Now I can take the square root of both sides, and I'm running out of room, so I'm going to come up here. Okay, so here we go. Take the square root of both sides. We get x plus 3/2 equals, don't forget, plus or minus, the square root of 15/4. Subtract the 3/2 to the other side. We get x equals negative 3/2, plus or minus the square root of 15 all over 2. Final answer. Again, it was the second step that was the most complicated of this whole problem. We're remembering what to add to the other side to keep it balanced. Okay, let's try another one. Okay, so here we go. Here's another one. 4x squared minus 16x plus 5 equals 0. Okay, if you want to try this on your own, you can pause the video now and do it. I'm going to walk you through it step by step. Because some of you still need to see this one more time. Okay? Very clearly I can see my a value is not 1. So I know I'm going to have to factor out the 4. So here's how I set this up. I'm going to group the 4x squared minus 16x together like this. You might think, Jose, that's so silly. All you're doing is adding parentheses. I know. Okay? I know what I'm doing. This helps me visualize what I'm factoring the 4 out from. Okay? So then I factor out a 4 of just those two terms. And I get x squared minus 4x. Leave yourself a space. Leave yourself a space because we're going to complete the square. This one's a little bit nicer. So when I complete the square, I take my b value, which here is negative 4. I divide it by 2, and then I square it. So negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4, so I'm going to add 4. Now, the most common mistake that people that did not pay attention to the last example are going to do is they're going to come over here and they're going to say, oh, to balance this out, I need to add 4. No, 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 you're not adding 4. Remember, what is happening to everything inside this set of parentheses? You're right, it's being multiplied by 4. So really what we should add is 4 times 4, which is obviously 16. If you wrote plus 16, that's fine. I'm just showing you that you have to remember to multiply by the number you factored out. Okay, so let's go through this and clean this up. We've got 4 times x minus 2, the quantity squared, plus 5 equals 16. Let's do some algebra magic here to get to get x minus 2 squared by itself. We get x minus 2 squared all by itself doing two things. Subtract 5 on both sides, divide by 4. So you get 11 over 4. Now we can take the square root of both sides, so we get x minus 2 equals plus or minus the square root of 11 over 4. Add the 2 to both sides, so we get x equals 2 plus or minus the square root of 11 all over 2. Final answer. It's not bad, okay? It's not bad. All right, let's see if you can try one. Definitely pause the video here, and I want you to try this one on your own, okay? Try this one on your own and see what you can do. All right, if you have, hopefully you've gotten this worked out, or you probably pressed play because you got stuck. Whether you worked it all the way out or you got stuck, thanks for trying. Okay, so here we go. I'm going to walk you through this. So the first thing I do is I group my x terms together in parentheses. That helps me remember what I'm factoring here. So I'm going to factor out a 3. So as I do that, okay, this is not as convenient because 10 is not evenly divisible by 3. So I have to, unfortunately, leave it as plus 10 thirds. Okay? Now, this one's where it gets a little spicy. Okay? It gets a little spicy here with what we're doing. We're taking b divided by 2 and squaring it. So what I'm going to do, actually, is I'm going to write myself a few things down here. I'm going to do 10 over 3 divided by 2. Okay? 10 over 3 divided by 2. Now, of course, 10 over 3 divided by 2 is the same as taking 10 over 3 and multiplying it by 1/2. Okay, multiplying it by 1/2. So then from here, I see that this 2 is going to turn into a 1, and this 10 is going to turn into a 5. So this is 5 thirds. 10 thirds divided by 2 is 5 thirds. Okay? Now, a lot of people will incorrectly put plus 5 thirds here. You're really proud of yourself for doing this work, and you're like, oh, 5 thirds. But if you do that, you forget that what you're supposed to do next is square that. Square that. So when we square that, we end up getting 25 over 9. 25 over 9. So that's the value that we're going to add to complete the square, 25 over 9. Now, to balance this equation out, I'm going to have to add something to the right-hand side as well. But remember, it's not 25 over 9. It's 3 times 25 over 9. It's 3 times 25 over 9. Okay? So then I'm going to skip this kind of scratch work that I did here. And I'm going to come right back down to here. Okay, so here's where I'm at next. So I have 3 times x plus 5 thirds, the quantity squared, minus 2 equals, now what in the world is 3 times 25 over 9? This 3 becomes a 1, this 9 becomes a 3. So that's simply 25 over 3. Okay, so it's just some simple algebra to get me to where I need to be. 3 times the quantity x plus 5 thirds squared equals 25 over 3. I'm going to add the 2 to both sides, but hopefully you know by now I'm not going to write plus 2. I'm going to change that 2 into 6 thirds so I can add those together. So I get 3 times the quantity x plus 5 thirds squared equals 31 over 3. Divide both sides by 3. We get x plus 5 thirds quantity squared equals 31 thirds times 1/3, because remember, multiplying by 1/3 is the same as dividing by 3. So I'm already out of room. And I'm at this, the quantity x plus 5 thirds squared equals 31 over 9. Next step, square root both sides. X plus 5 thirds equals plus or minus the square root of 31 over 9. subtract the 5/3 on both sides, and you get x equals negative 5/3 plus or minus the square root of 31 all over 3. Not bad. We got a little spicy there with our arithmetic because we had some ugly fractions to deal with, but you made it. Okay, if you got that on your own without me, man, that's impressive. Pat yourself on the back. Okay. Now, if you need to take a break because this last problem is a doozy. This is super spicy. You might need to go get a glass of milk, get a towel to wipe the sweat off your brow because it's going to get spicy. Okay, here we go. Let's have some fun. All right, example number 8. I skipped number 8. That should be an 8. Sorry, some of you super type A people are bothered by that. We can change it to an 8. Here we go. Solve for x. This is ugly right here. Your b value is very ugly. Okay? So let's walk through this together. If you're feeling super courageous and you want to try it, man, pause this video right now and you go for it. You go for it. But I'll give you kind of a head start here. Okay, I'm going to start this the same way that I have all the others. I'm going to group my x terms together. And what I'm going to do is I'm actually going to rewrite that b term. I'm going to slide the radical out in front of the x. What that does is that helps me visualize that the b term is actually both 2 and root 3. Both of those are included in my b value. Okay? All right, so here we go. So what we're going to do next is we're going to see that we have to factor out the 3. Okay? So we've got 3 times. I'm probably going to even need to change to the smaller font size because I'm going to need quite a bit of space for this one. All right, smaller font size. Here we go. So factor out the 3. Okay? And we've got x squared left over minus 2 root 3 all over 3x. Leave yourself a space. Plus 5 equals 0. Okay, this is difficult to figure out what you're adding to complete the square on both sides. Now, if your tendency is just to grab a calculator and punch it in, you better put that thing away because for the quiz and the test, you will not have a calculator for this. So we need to know how to do this arithmetic. So here we go. We're going to take 2 root 3 over 3, and we're going to divide it by 2. Now, instead of dividing by 2, I'm going to multiply by 1/2 because it's the same operation. It's the same operation. Now, when I do that, this works out pretty nicely. I see this 2 and this 2 cancel out. So what I have left over is I have root 3 over 3. Root 3 over 3. All right. Now, don't make the mistake of thinking that that's what you use to complete the square because you're almost there. You have to square it as well. So we're going to take root 3 over 3 and we're going to square it. Okay, root 3 over 3 squared is 3 over 9. Now, 3 over 9 is a fraction that can be simplified to 1/3. Hey, that wasn't as bad as I thought it was going to be. Plus 1/3. But don't you dare forget to go to the other side and also add, not 1/3, 3 times 1/3, which works out super nice as just 1. So here we go. I'm going to skip my scratch work and come down here. So we've got 3 times the quantity, x minus root 3 over 3, the quantity squared, equals, and hey, just if you have missed this the whole time, you're like, how does he know that that's minus? Remember, it's going to be the same sign as you had in your original perfect square trinomial. The sign and this sign will match. Okay? So here we go. Equals. I shouldn't put the equal sign yet because that's a little too much to do at once. So I'm going to come back and I'm going to put my plus 5 that I still have there equals 1. Equals 1 because 0 plus 3 times 1/3 ends up being 1. Okay? So here we go. I'm going to subtract the 5 on both sides. And what the heck? Let's also divide by the 3. So let's do x minus root 3 over 3, quantity squared, equals -4 when I subtract the 5 over 3. Take the square root of both sides, we get x minus the square root of 3 over 2 equals plus or minus the square root of -4 over 3. You don't have to be afraid of square roots and negatives anymore because you know what to do. Okay, so here we go. Let's clean it up. We've got x equals, add the root 3 over 2 to the other side, plus or minus 2i all over the square root of 3. Now you, in this stage of mathematics, should not stop here. You should not leave radicals in your denominator. Don't leave radicals in your denominator. Also, don't make the mistake of saying, oh, this root 3 here and this root 3 here will cancel. That is not true. They don't cancel because the operation that's happening between these two fractions is addition and subtraction. If it were multiplication or division, you could eliminate the root 3, but you cannot do that here because, like I said, we are doing addition or subtraction. So you got to remember how to get rid of a radical in your denominator, and you multiply by root 3 over root 3, just on this fraction. You don't have to do anything over here. This one's fine. We're just multiplying by root 3 over root 3 on the second fraction. So here we go. We have x equals the square root of 3 over 2, plus or minus. Let's do 2i root 3 all over 3. And that, ladies and gentlemen, is awesome. And that also is the conclusion of this lesson. So I hope you enjoyed completing the square. Please don't hesitate to reach out to me if you have any questions, comments, or concerns. If not, it's been a pleasure. Enjoy the rest of your day or night or wherever you are.